My name is Tomasz Jach. I come from the University of Economics in Katowice, and I will be presenting today the paper called Modeling an IT Solution to Anonymize Selected Data Processed in Digital Documents. First of all, the project plan or the presentation plan over here. As usual, we're going to start with the introduction to briefly explain the problem and the aim of this paper. And touch a little bit about the data detection algorithm that we used. And then we're going to explain our research methodology along with the experiments and their results. As usual, we're going to end with conclusions and future works because this paper is going to be a part of the series or a first part of the series of future works. Okay, so in order to completely understand the problem, we have to specify what do we understand about the anonymization. So the project problem comes from the legal basis. The legal cancellery or the lawyers tend to use, read, and analyze a lot of documents. These documents are most of the time very difficult to analyze. In order to do that properly, sometimes the law offices need to contact each other. And then comes the problem with identifying data, the so-called PII, personal identification information. That data is usually not transferable between law offices. By transferable, I mean there's no legal procedures giving the explicit allowance to use the data outside the lawyer office. That's why one of the law offices that was part of this research asked us to provide some means of the anonymization of documents, but to anonymize documents to leave so much information that one can understand what was inside the document prior to anonymization. So the process is important to protect individuals and institutions from the illegal dissemination of information, as it is over here. And what's most important from this slide, it's 95% of the times, even 100% of the times currently conducted by manually by trained employees in law firms. That introduces a lot of latency, a lot of time problems, and a lot of errors, as it's going to be shown in the experiment section. So the aim of this paper is twofold. First of all, is to show how important and at the same how difficult is the task to identify personal or corporate data of a client. By the way, by corporate and personal data of the client, there is no strict definition of this kind of data. Depending on the law in different parts of country or different parts of the European Union, that kind of differs and makes the task even more difficult. There is also a research goal over here to check and evaluate the usefulness of IT techniques as well as decision rules, patterns, any other types of algorithm that we have thought through to anonymize the legal documents or to de-identify the documents. All right. In order to do that, the first task was to really identify what needs to be anonymized. So what are the personal information, what are the data that needs to stay or that needs to go away. In order to do that, we have worked with the law offices over here in Poland in order for them to provide us with the samples of the anonymized documents. And that was the first obstacle from the project, because when we gave the same document to different people, basically only part of the information that was anonymized matched. A lot of verbs, a lot of nouns, and a lot of words, to be general, was anonymized differently by different people. Having said that, we spent a good part of work of establishing the good practices of what needs to be anonymized. Furthermore, for inflectional languages such as Polish language, all the searches using real-world data are prone to additional errors due to multiple forms of the same word. So due to deflection, most of the algorithms, the natural language processing algorithm, are more difficult to implement because of deflection, because of the lemmatization algorithm, don't work for proper names like company names. They do work well for the common names, but not for the proper names. The same goes in the case of data related to digits. So having the 9 digits number, you can think of it as a phone number, you can think of it as a company registered number, and any other numbers or any other meaningful or meaningless numbers. Only the semantic context might indicate whether we should anonymize that number or it's benign, for instance, some currency number or some money number. The proposed method over here was conducted and was proposed as a something which is created by 5 different types of searches or 5 different types of algorithms. First of all, there's a standard dictionary search when we have a fixed dictionary for words that we are looking for. For instance, that was the very good idea for names, the first names in Poland, because the list of first names from the national PESEL database, this is the national database of all citizens in Poland, is publicly known. So we can have the full list of every first name inside Poland. Second type of proposed method was to create decision rules and patterns. That was most of the time done via the regular expressions, but also via some decision rules. As I said before, some numbers only matched to a certain PII type of data only because of the context. The third type of a method was a special type of validation for self-checking numbers. Polish national numbers such as PESEL, such as NIP, so company number, such as I think KRS number, if I believe correctly right now, have a self-checking validation method via the LUN algorithm or Luna algorithm. The fourth method was to validate numbers, especially numbers, using external services. So there are some external services which provide application interfaces in Poland. Then you can validate whether the particular set of 9 digits numbers is actually a company number in Poland. Last but not least, there's a heuristic search using some of the known patterns, like every private limited company in Poland has to include the SPZOO inside the name. So we can use that to provide the heuristic approach that probably the capitalized words before that pattern form a name of a company. The computational experiments was conducted over 2 data sets. The first one was the artificially created test that contained 50,000 false identities. So 50,000 rows, you can think of it as rows in database terms, with names, companies, addresses, and other confidential information or other PII information, where we wanted to test the efficiency of the proposed solution on a large amounts of data. We conducted this research on this fake identity test. When then we validated the results on the set contained legal documents written in Polish, where we performed the actual anonymization. So the results for the first artificially created data sets are shown on the slides over here. For the 5 types of PII information shown on the bottom, like name, email, and NIP number is the Polish company number, phone number and KRS number, we have identified we have produced over here the box plot of the number of matches found. The perfect solution is shown for the email, so exactly 1 number of matches found. That means that for every row inside this 50,000 fake rows or 50,000 artificially created rows, inside every row, there was exactly 1 of the types of PII information over here. So for the email over here, we have identified all of the emails from the database. and didn't introduce any false positives. That was the case for the name. So there were a lot of false positives for the name. This is because the addresses in Poland, and not only in Poland, tend to have the name of famous people inside it, like the street named by the famous poet or famous astronomer or a famous person. And that's why the number of matches found increased. For the numbers, like the phone, KRS, and NIP number, that situation was because of these numbers were just a sequence of numbers, a fixed length sequence of numbers. Sometimes the random sequence of numbers has such as NIP number, even though it's self-validated. This random sample produced a perfectly validated result. For the set of real legal documents, the set contained 15 legal documents written in Polish and relating to various legal scopes and cases. Originally, all the documents were given to us with proprietary Microsoft format, docx format, and they were converted into a text one, doing some cleanup of the data, like to change all the letters to small ones, to remove all the punctuation, and so on and so forth. The documents were of different length and the numbers of words per line, that kind of mattered, if we're going to see that in the experiment results. And it was observed that the low number of words per line is usually related to the short information provided in the legal document. So the preamble, like the address part, was usually consistent with the short length of numbers. Over here, there are the features of the documents analyzed. As we can see, there are 15 of them. Most of them so the average number of words per line is 6.5 over here, but that varies a lot for different documents, as we can see over here. There were about 3,000 lines total in all of the documents, and about 20,000-ish words that each of these words could be anonymized or could be anonymized. In order to provide a consistent scoring or consistent results, we tend to use the confusion matrix with all the values over here, like true positives, that elements that really should be anonymized for the reason given and that were actually anonymized. The false positives, false negatives, and true negatives understood as it's usual inside the data science / machine learning over here. On top of those metrics over here from the confusion matrix, with all the stakeholders, we have presented the 3 standard measurements of classification evaluation. That was the precision, the recall, and the F-score, the standard F-score. The precision measurement determined with what certainty we can trust that the classifier that the given element word should actually be anonymized. The recall, on the other hand, determines how many elements that should be anonymized in the document have been indicated as anonymized, so think of it as a completeness. And the F-score, as usual, tends to balance or tends to use those 2 metrics together to provide a single consistent number. For the results of the anonymization documents, this is just a part 1, part 2 over here. Some information or some information was given for the name. For instance, on each of the document, there were some kind of names that were anonymized, either properly. That's why the true positives numbers are quite high over here. There were a lot of false positives. Most of them, like 90% of them, were due to the fact, as I stated before, that sometimes in the address part there were a name of a famous person, so that the algorithm found it and thought it as a name that should be anonymized. For the email, There weren't much of the emails inside the documents. Inside document 6, we found 3 of them that were true positives and 1 false negative. The perfect situation was for the company number, that's NIP number in here, because all of the documents, all the numbers that were there were actually anonymized. So we had the perfect score of true positive over here. The solution didn't work 100% for different numbers such as KRS or phone number over here or a company name, because those 3 categories are the toughest to find or the most difficult to find. As I said before, the company names could not be taken from the direction. Because of that, we had to find some heuristics which tend to work quite okay, not on every case over here. Overall, all in all, the average precision for all of the documents was about 80%, so 0.8 on average. For the recall parameter, that was about 88%. With all the stakeholders, with all the legal offices, we found out this is quite okay achievement for the first phase of this solution, because on top of those phases, on top of those results, we're going to introduce the more sophisticated machine learning algorithms, more sophisticated natural language processing algorithm over here. What's more important that it's for some of the documents, we obtained a perfect recall, and for some of the documents, we obtained a perfect precision. It is to be determined by the stakeholders, by the law firms used over here, how to precisely tune this algorithm in order either to mark as PII information or anonymize more of the words and tend to anonymize something which should not be anonymized, or to leave out the information that should be anonymized. Of course, most of the law firms
1 minute left, so
prefer to anonymize something more. And not to leave for instance, the personal identification number that should be anonymized, because that's a breach of confidentiality. For the conclusion, the research objective was to analyze a limited range of data. Only a selected type of data was anonymized. One can think of a different PII information, such as, for instance, the identifying number of the document inside the legal practices, or any type of indirect information. So not having my PESEL number shown, but a person who lives in this city, who lives on this flat, or has this fiance or this wife over here. The algorithms won't be able to anonymize all of that, indirect information. However, they tend, or they start, or they want to provide maybe some means to find it or to assess it. We wanted also to assess the applicability of IT techniques and decision rules and patterns in document anonymization, and that kind of proved itself inside the experiments. The conducted experiments confirmed that the solutions we have applied allowed us to obtain good results. So, as I said, 80% of recall, 88% of recall, 80% of precision. It is worth to develop the modeling of a machine learning on a bigger group of real legal documents, because, as I said, for the Polish documents, there were only 16 of them, so a quite low number of actual documents, of real-life documents. And the future work may include developing a multi-criteria model for a multi-step analysis, so possibly to initially verify the data, and then to provide a machine learning algorithm which is going to fine-tune or just work on this preliminary set of found data. Thank you very much.
Thank you. It was quite interesting presentation and, of course, research. Do we have any questions? If not, I have one question related to content of documents, because in document we have not only text but also graphics or some information in graphic form. Have you any approach how to anonymize this kind of information? Thank you.
Thank you very much for that question. So for the first step, we only concluded for the textual information over here. That was the requirement from the business stakeholders. However, one of the first steps, as I said, was to clean up the textual data. And in parallel for that first steps, we're going to use some optical character recognition in order to find out the text which is inside the scanned documents. In fact, for some of these documents, for some of these docx documents, that was actually the case. So even though it was a textual format from MS Word, from Microsoft Word, it was actually the image scanned put inside the docx. So we had to do that.
Okay, thank you. We have another question. So Professor Grabara.
Good morning, and I have one question about your pattern classification, because you have done already for this the classification for the emails. Have you used regular expressions there, or any other pattern classifications method, or just regular expression was enough for determining is it email or not?
So thank you very much. In fact, this was the regular expression, but not just a simple one. So we had to fine tune it because just finding the @ sign wasn't enough.
It's not enough, yes.
It's not enough. There were some rules about the length of the domain part, having actually the domain part, which wasn't exactly the case, like just to find something with a dot and 2 or 3 characters, because the domains for a couple of years right now are quite bizarre and quite different. So
yeah. Okay, thank you very much.
Thank you.
Thank you, and of course, Professor Ziemba also raised a hand, so please ask a question.
And maybe one simple question: where your method can be used in practice? Where and did you have some experience in practice or not?
So thank you very much. Yes, in fact, that method is actually used inside one of the existing law companies or cancelaries over here. They were the ones providing us with the real world samples over here, and they are fine-tuning the algorithm and fine-tuning the process. As I said, this is a part of a bigger picture, because they want to be the cancelari that's standardizing this approach through different other ways. The approach is not only strictly combined to the legal documents. In fact, it can be applied to any kind of anonymization of PII data.
Thank you.
Thank you.
So thank you very much. One question more, so from Professor Wątróbski.
Thank you, Oscar. I have one question strictly connected with your future research avenue. Could you briefly explain what the plan about the multi-criteria model building? It was pointed by you as a future work avenue. Do you have any plans? Do you have any models development or something like that? Thank you.
Okay, thank you very much. So that probably was not very clear over here, but inside our first phase approach, we mostly wanted to find the single words or single digits or single tokens, what's called like this. So the algorithm highlighted the single words that should or should not be anonymized. That's not the perfect solution for the names, for the PII information that consists for multiple words. So one of the first solutions is to, and it's happening right now, to use the bigrams, trigrams, and other forms of grouping of the semantics of the tokens. That's one of the research patterns over here, not just to find out the single words, but just to analyze with more context over here.
Thank you.